All right, today we're going to take a look at problems 14 through 23. I'm going to kind of get you started on those and give you some tips for how to proceed. So here we are in Google Classroom. I'm going to go into Geometry. I'm going to go to Classwork. I'm going to go down here to Unit 1. That's currently where we're at. I'm going to open up a couple things. I'm going to first open up Guide to Problems 14 through 23. Open up the PDF there. I'm going to go over here and open in a new window, keeping in mind that they'll always be in Unit 1, but they may have moved up or down in the lineup since I've done this video. And then we'll go down here to Unit 1 problem set, open that up, and we'll open up the PDF there in a new window. Alright, so let's move forward to problem number 14. Zoom in here a bit. Okay, it says, draw a 20 by 20 square, A, B, C, D. So the four corners of the square should be labeled A, B, C, and D. Mark P, point P, on AB, so that's on the first side between A and B, so that AP, the distance from A to your new point P, is equal to 8. And you put Q on BC, that's the next side, so that BQ, and BQ means the distance from B to Q, is 5. So Q should be 5 spaces from B. Then we're going to put R on the next side. That's side CD. So that CR, and that's the distance from C to R. So R should be 8 units down from C. And then last, S, it goes on side DA. And again, DS should be 5. So D should be 5 units from S. So once you have your square ABCD, you're just going to go, start at the top and down 8 spaces, and you mark a point. Go to the next corner, you're down 5 spaces, you mark a point. Go to the next corner, over 8, mark a point, and then down to the end, and then up 5 spaces, and mark your last point. And then you connect the 4 points you just drew to make a parallelogram, or not a parallelogram. Well, okay, I gave it away. It's a parallelogram. Isn't there anything special about this quadrilateral? So there's your answer. All right, next, if you take a look here, I did give you in here, okay, some notes about the notation, what that means, segment AB, and so on. And your sketch is going to look something like this, but much larger. There you go. All right, so for number 15, you're supposed to plot points P and A and B, and you're supposed to show that P is the same distance from A as it is from B. And that means the word for that is equidistant, same distance, equidistant. Then you're supposed to find 3 more points that are equidistant from A and B. And it says, by the way, to find a point means we want to give its coordinates. So then, and here I plotted point A and B, and there's P for you, so you just got to copy that down. Here's an additional point C. C is the same distance from B as it is from A. You can do the calculations to show that. So see if you can find a pattern that kind of comes together when you plot the rest of these points that are the same distance from B as they are from A. By the way, to find 1 more of your own, you need to find 3 of your own, but to find 1 more of your own, think about midpoint. If you're having a little trouble with midpoint, click here. There's some information on midpoint there. Next, problem 16. Got this diagram. It says the 2-part diagram below. How is this proving the Pythagorean theorem? If we go back here to our notes, I've given you a couple different examples of that diagram, but with actual numbers attached to it. So, one, you can watch this Math Antics video about Pythagorean theorem, where he talks about areas in Pythagorean theorem. But then again, I've given you some things to think about, how these different shapes are put together. So just read through that. Okay, 17. Inside a 5 by 5 square, it's possible to place 3, 4, 5 triangles so that they do not overlap. Show how. Then explain why you're sure it's impossible to squeeze in a 5th triangle of the same size. So go back here. Here's your 5 by 5 square. Notice you're going to have to draw it, kind of tilt it on its side for this to work. And to do it, from vertex to vertex is over 4, down 3, down 4 over 3. You can see the pattern here. So you'll have to sketch it like that. Here's the 3, 4, 5 triangle. Notice it's a right triangle. We use our Pythagorean theorem here, 3 and 4 and 5, with 5 as the hypotenuse. So it is a right triangle. You should be able to fit 4 of them in there. If you think about area of a triangle, and the area of those 4 triangles, and the area of the original square, hopefully that should kind of clear up why you can't fit a 5th in. Right. Next up, number 18. If you were writing a geometry book and you had to find a mathematical figure called a kite, how would you word your definition? Yes, you may be tempted to just go to Google and look it up and copy it down, but that will be in your own words. You need to be able to understand what you wrote down. I want your definition, not something you found online. So be prepared to explain your definition. Next, 19. Find both points on the line y equals 3 that are 10 units from the point 2, negative 3. So go back here. I plotted the line y equals 3. It's a little hard to see on this version, but this is, again, 3 units up from the x-axis. There's the point 2, negative 3. And here we've got that 3, 4, 5 triangle again. And there is a triangle that's similar to this, meaning it's a larger version of this triangle, which you can use to find the 2 points that are exactly 10 units away and on this line. Right? Notice 10 units is twice as big as 5. How many times bigger should the side lengths be on our similar triangle? Something to think about. Next we have number 20. On a number line, where is 1/2 p plus q in relation to p and q? So if you've got 2 numbers on the number line, p and q, and you do this calculation, and you plot the new number on the number line, where will that new number be? In relation to means, like, is it going to be in between them somewhere? Is it going to be before them? Is it going to be after them? Is it going to be right on top of one of them? All right. So I want you to be as specific as possible. To help you out, I've gone through here and I've picked 3 points right here, right? And I kind of plotted the first 2, on this number line. Again, if you copy the number line down, you'll be able to see that the 1 and the 7 and the 3 and the negative 5 and all those are actually on the grid lines, but the grid lines get washed out a little bit in this scan. So you just have to do the calculation. So, for example, 1 plus 7, p plus q, is 8, times 1/2 is 4, so the new number is 4. So you'd plot 4 over here. And just do that for these 3. Come up with 3 samples of your own. Look for a pattern. Describe it in as much detail as you can. What is that pattern? How is that new point related to the other 2? Number 21, some terminology. Congruent figures, they're the same shape and size. And I want you to dissect or cut up this shape into 2 regions that are congruent. So over here, I've given you, I want you to use these exact dimensions. So the shape is 8 squares, like units along the top, and 8 along the bottom, up 4 over 2 up 6, and just follow this. So again, the grid got a little washed out in the scan, but you should be able to recreate it based on those measurements. I've given you one way to cut it up, right down the middle here. I think that's actually like 1 unit down. 1 unit down. So that cuts it into 2 congruent shapes. I could take this one down here and sort of rotate it up and place it right on top of the other one. Now this uses a single cut. There's lots of different ways to do it, many of which also use single cuts or multiple cuts. So I want you to find at least 4 more ways to do it. Okay? I think finding 4 more at least will give you a little bit of a challenge. Next up, we've got 22, so it's 2 left. Okay, so they want you to plot A, B, C, and T, U, V, and then sketch them, plot them, sketch the triangles, triangles A, B, C, so you connect those 3 points to make a triangle, T, U, V, connect them to make a triangle, and how are they specially related to each other. And it says to make calculations to verify that statement. So we'll go down here. Okay. There's a video here that you can watch for a detailed explanation of exactly how these triangles are related. And then the calculations you'll have to do to show that this relationship is true will be Pythagorean theorem. You're going to be calculating the lengths of the sides of the triangle. And then, in the second video, we'll talk about translations. And bonus if you can bring in this idea of translations into your discussion of the relationship between these two triangles. Last problem, number 23. A triangle that has two sides of equal length is called isosceles. Make up an example of an isosceles triangle, one of whose vertices is the point 3, 5. So if you can, find a triangle that does not have any horizontal or vertical sides. Well, doing it with horizontal and vertical sides is pretty super easy. I've given you, however, 4 different samples of ones that have and that don't have horizontal sides. And notice again the grid lines get a little washed out, so I think I'm going to have to come back in here and add the actual coordinates so that you can do that. But I'll do that in a little bit here. So you'll have the coordinates of these other vertices so that you can actually plot them. You can do the calculations and check that they are what you call isosceles triangles. And this last one here is a little different from all the others. Let's see if you can figure out what's different about that one. All right? And if you have, of course, as usual, if you have any questions about this, feel free to ask me in class. I'd be more than happy to help you out. Good luck.